I'm Stacey Koprince. I'm the Director of Content and Curriculum for Manhattan Prep and also a Manhattan Prep GMAT instructor and EA instructor. I'm here with my colleague, Ryan Jacobs, who's waving, who is the one in the hot seat tonight. He's the one who is taking the test, who's twitching the test. This is the third of three. So there are three sections on the new GMAT Focus. There's data insights, which Ryan did in our first session, like 6 weeks ago now. There's the verbal section, which he did in our second session. And tonight he's going to finish it off with the quant section. And then he has been taking the same test this whole time and just pausing the test. So when he's done with his quant section tonight, he will also reveal to us his score. And not to increase the pressure or anything, Ryan, but earlier today, I took a practice test myself. And I also, like you did a few weeks ago, I screwed up the timing in my data insights section. And I ended up having to guess on a few questions just to be able to finish in time. And I'm so annoyed because there were questions that I totally could have gotten if I hadn't had to guess to finish. And I did only score in the 98th percentile instead of the 99th percentile. So you can't do anything about it now, but except for try to do really well in the quant section.
Yeah.
For those of you who weren't with us originally, Ryan had a rough for DI section for the first section. Do you want to say anything, Ryan? Or are you like shut up?
Nowhere to go but up.
Yeah. I'm not trying to increase the pressure. There's already enough pressure. Anyway, so you're going to take this section and then I'm going to ask you right at the very, very end, because as soon as you click that you're done with it, it's going to pop up your score. So I'm going to ask you right at the very end, before you click on that, tell us, like, make a guess, tell us where you think you scored.
Yeah.
And then moment of truth, and we'll see what it actually is.
Sounds good.
And as we're going along, if you have any questions, if any questions pop up that you would like to see us discuss after Ryan's done, you can go ahead and pop that into either the chat or the Q&A feature. You can also just write it down on a piece of paper and tell us at the end of the test. We'll be going back and looking at the questions. Oh, you know what? I don't need to take screenshots of everything today, do I? Because you're actually going to finish the test and then we can scroll back through.
That's true.
Huh. All right. This is going to be easier for me than it was the first two sessions when I was frantically trying to screenshot everything. Oh, you know what, though? I do want to screenshot your practice work. So I will do that so that we have that and we can go back to that. All right. All right. Anything else you want to say before we dive in, Ryan?
I'm just really excited to actually see my score this time. It's very weird taking a practice test section and then not knowing how you did.
Right afterwards, right? You've been waiting weeks to find out.
Yeah.
All right, good luck.
Time to make.
Let's do it.
Cool. So practice exam number 1, resume test. And this popped up full screen for some reason. There we go. All right. And
so this is where Ryan paused in his prior section verbal.
Yeah, so time has run out. Okay, cool. Optional break.
You just took a 3-week break. We're good.
Yeah, okay, so begin the break. This would be my break. Cool. Let's go. All right, instructions. Thank you. Next. Cool. We're in it. Scratch paper time. Boom, boom. 2, 10, 18, 26, 34. If root 1 plus root 1 plus root x equals 2, then x equals, well, let's just square everything. So 1 plus root 1 plus root x equals 4. Oh, but this is trickier than I thought it was going to be. So root 1 plus root x equals 3. Square it again. 1 plus root x is equal to 9. So root x equals 8. So x is equal to 64. Final answer. Little algebra problem to start us off. Let's go. All right. Word problem. Sharon and Rum left frequently mother, grandfather's yard. We're in normal pace. Okay. So yards per hour times hours equals yards. And we've got Sharon and Ramla. and then together. So we're going to normal pace. Sharon can mow the yard in 5 hours. 1 yard, 5 hours. And they work together. They can mow the yard in 3 hours. And how long? Okay, so we want to know that hours, and it's 1 yard. Okay, so 1/3, 1/5, 1/5 plus some rate is going to equal 1/3. So x is equal to 1/3 minus 1/5, 5/15 minus 3/15. That's 2/15. So this is 15/2. That is 7.5. Done. Next question. Another word problem. All right, during a certain year, 80% of visitors to Smithsonian institutions were United States citizens. 50% of the remaining, and then 50% of something else. Okay, so let's just assume 100 visitors total. This looks like a pick numbers problem. 80%, so that would be 80, were from the US and 20 were not. 50% of those remaining, so that would be 10, were Canada or Mexico, and then 10 not. And then 50% of the visitors who were not US, Canada, or Mexico were citizens of European countries, so 5 Euro and 5 other. Sorry, that's getting a little ugly. Number of United States citizens who visited the Smithsonian that year, that would be 80, was approximately how many times the number of citizens of European countries? So 16 times, right? I hope. That's cool. Next question. Which of the following is equal to, this looks horrible and I'm just going to estimate it, the square root of 6 minus, well, actually, wait, can I rationalize the denominator? Yes, I think I can. I don't know whether I want to do algebra here, but I'm just going to do it. I'm committed. So we're going to multiply this by root 6 minus root 2 on top and bottom. 6 minus root 2. And that's going to create a difference of squares in the denominator. So up top, I get 6 plus 2 root 6 root 2. And then plus 2, I'm sorry, minus. I almost messed that up. Over 6 minus 2, which is 4. And this is 8. 6 plus 2 is 8. So I get 2 times all this. So 4 times the square root of 12, which is equal to, oh God, doesn't look like any of the answers. Well, root 12 is square root of 4 times root 3. So 4 times, so 8 root 3. What is that? I have no idea. I should have just estimated. Okay, we'll come back to this later. I'm going to guess. Let me just estimate now. So what is root 6? That's like 2.5. So it's got to be less than 1. A lot of these, oh God. Well, this is probably a root 3 in there. I'm just going with, we'll come back to that if we need to. That's just a guess. X is a multiple of 18 and 60. Then X must be divisible by which of the following? Oh, prime factorization problem. Okay, so X is a multiple of 18. 18 is equal to 2 times 3 times 3. 60 is 12 times 5, right? So 5 and 12 is 2 times 2 times 3. So there got to be 2 3s, 2 2s, and 1 5, but that's all we know. So is it definitely divisible by 24, which would be 2 2 2 8 now because I got that extra 2. 36, that's a lot of twos. No, it's not divisible by that. Is it divisible by 45? It must be, because only one answer choice would make sense. But yeah, okay, so 3 only. Oh, wait. Oh, God, that's not an answer. What did I screw up? Oh, I screwed up the prime factorization in 24. So 2, 2, 2, 3. Wait, but it's still not. Oh, no, I screwed up the prime factorization of 36. 9 times 4. So yeah, okay. So 2 and 3. Whew. Right method, but I made a silly mistake. Maybe response. Am I still okay on time? Yes. Okay, so normally I would be able to save that if this were the actual test center, but let's just do it again. 2, 10, 18, 26. Let's go. Rule of 72 states that to approximate the number of years, takes the sum of money invested at K% annually to double. Divide 72 by K. Okay, Eric invested 10,000. 8% compounded annually. So K equals 8. The investment had grown to 20,000. So we assume that that's 72 years. He invested that sum at 12% compounded annually. So K would then equal 12. According. Oh, not 72 years. It's 72 divided by K years. So that's 72 divided by 8 years. And this is 72 divided by 12 years to reach 40,000. So how many years is that? That's 9. That is 6, right? So 9 plus 6 is 15. Yes, that is an answer choice. Let's go. That's just, the math is easy, but the question is hard to understand. All right, X is a K-digit integer, and X is, so 4 to the 9th times 5 to the 17th. The trick is we got to make this into 2 to the 18th times 5 to the 17th. And then we get a bunch of 10s, right? So that's going to be equal to 10 to the 17th times 2. So that's 2 with 17 zeros. That's going to be 18 digits, not 17 digits, trap answer. So 18, next. Certain state charges no sales tax on food. It charges a sales tax of 2% on clothing. Where is this state where I can eat for free? Sounds lovely. Sales tax is 6% on all other items. Sarah purchased items with a total price of $210. And this is before tax. Okay, so 45 for food, 90 for clothing. And I'm assuming we're going to need to know how much remains. So 210 minus 90 is 120, 45, 75, other stuff. Total sales tax was what percent of the total price? Well, can we just figure it out? So clothing, 2% of that would be $1.80. 6% of this would be 0.75. 4.5, 450. So 450 plus 180. Let's just calculate it. There's probably a faster way to do this, but I'm just deep in. So 630. Oh, but that's going to divide evenly, right? Yeah, because 63 over 21 is that's 3 exactly. So 3%. That's nice that they made those numbers friendly. Okay. Moving on. On the number line, which the following specifies the set of all numbers x such that, ooh, oh God. I already have one that I want to come back to. Let me just see if I can hack my way to an answer here. So where is this going to be equal to 2? X minus 3 plus x minus 4 is equal to 2 at 2x minus 7 equals 2, 2x equals 9, so 4.5. Then we have negative x plus 3 plus x minus 4 is equal to 2. But I don't know. Oh, God. No, I don't want to do this. And then I'd have to test all those numbers. I hate this question. I'm coming back to this. I'm just going to guess 4.5 because yeah, that's the one that I found. So go with that for me. And I'm just going to make a note at this point that that was question number 9. So 4 and 9. Good. That'll be easy to remember because the 49ers, my favorite football team. Those are the ones I want to come back to. Normally, I would be able to keep that on my scratch paper. But all right, how am I doing on time? Oh, I'm really good on time, though. So I'm happy with that. 2, 10, 18. This looks like a weighted average question. A certain amount of 8% copper ore was mixed with another amount of 3% copper ore. And we want to be right here, which is 2/5 of the way in between. So that's 6%. How many tons of the 8% copper ore were used to make this mixture? Well, it would be 3/5 this and 2/5 that, so it's 3/5 of 300. That would be 300 over 5 is 60. 3 times 60 is 180. Is that an answer choice? Yes, it is. Cool. S is the sum of all the numbers. Oh, okay. So one, this looks challenging. ... Plus 1 over 63 plus 1 over 64. That's S, right? Let me just double check. Yes. Cool. I'm going to estimate this. Oh, wait. Oh, no. I know what we're going to do. How many numbers is that? That's 32 numbers. So it's 1 over 32 times 32. It would be less than that. And 1 over 64 times 32, it would be more than that. So this is 1, this is 1/2. It's somewhere in between. I hope that's an answer. Yes. Boom. There's a problem like that I've done, by the way. So when we talk about it, we can come back to that idea. The range of a function is the set of all possible values of the function. Thank you. If the function f is defined by f of x, oh, so how big can that get? How small can it get? Good question. Well, x has to be positive. So what we can't have is stuff like 1. This is never going to be negative. So let's see what answer choices we can get rid of. All real numbers, no. All real numbers except -1, no. All positive real numbers, maybe. All real numbers greater than or equal to 1 and less than or equal to 1. Okay, so can we make it bigger than 1? No. So C is out. Oh yeah, and E is out. So because E would include negatives. So I'm pretty sure it's D. I'm not 100% sure, but actually have to click on D. That would help. Yes, cool. Certain law firm has 28 lawyers and has offices in 3 states. Well, they're doing well for themselves. Every lawyer in the firm is either licensed in all 3 states or is licensed in only one of the 3 states. 10 lawyers are licensed in the state. Oh, God. Okay. Here's what we got to do. The number of lawyers is X plus Y plus Z. And that is 28. But the number of licenses is, oh, wait, hold on. No, I should, yeah, okay. I'm going to do it differently. So 10 plus 11 plus 13 is the number of licenses. That would be 32, right? No, 34. Do math. Come on. Okay. So there are 34 licenses total, but only 28 lawyers. That means that 3 of those, right? So 25 are singletons and 3 triple threats. Because these account for 9 licenses and 25 plus 9 would get me to 34. Oh, okay, yeah. And then in state Z, there are 13 lawyers. And because I know that 3 of them are in 3 states, subtract 3 for the ones that have a single license, that would be 10. Ooh, God, that's a weird, this is funny because I've seen something like it, but never that exact thing. They threw me for a little bit of a loop in like the reading and understanding of that. So tricky little question. All right, how am I doing on time? I built a cushion of 8 minutes. I am happy about that. That's going to allow me time to go back to those other 2. Whew, 210. Let's do this. At a recent sale, Haru bought various numbers of 5 types of school supplies. Each advertised with different pricing strategy. Oh, okay. What are 5 types? Oh, let's see. Buy one, get one. Oh, wait a second. So if we buy one and get one at 50% off, that means, like, let's say we buy one for $60. We get another one for $30. So that would be $90 for 2 instead of $60 for 1. So that's basically, we're gonna get 2/3 for the price, or 1 for the price of 2/3, I think. And so if I just triple that, it's going to be 3 for the price of 2, right? So it's pins, I think. I'm not 100% sure about that either, but I don't want to think about this anymore. So what is that? 14. All right. So that's 3 that I need to come back to. I can't really skip anymore unless I just want to sacrifice one. So 10 circles, all with different radii, are positioned in the same plane. What? Oh God, why did I skip that last one? Let's see. 10 circles, all with different radii or positions in the same plane. What is the maximum possible number of distinct points where two or more of the circles intersect? So let's just like make, so that's going to be like two intersections already. Let's see if we can just find a pattern. 2, 3, 4. So circles, intersections. If we have two circles, that's two intersections. If we have three circles, that's 6 intersections. What if I have 4 circles? This is going to be the tricky part. Yeah, that's not going to work. Got to be some other way to do this. $180. I don't like this problem. That's a guess. It's a wild guess. Difference of squares. Thank God, something I can do. 99. Oh, wait. Tricky difference of squares there. Hold up a second. Yeah, I still do have to factor it right off the bat. 999 plus 1 times minus 1. So I'm just going to do that right now. This is 100,000 times that. So that is this minus 2. And this would be 10 to the 1, 2, 3, 4th power. This would be 10 to the 5th power. Is that an answer? Yes, that's interesting. Yeah. Promotional video, the last W minutes, has 3 segments. Okay. X, Y, and Z minutes. Total W. Celebrity host name. It's 1/3. For the second segment. And of the third segment. And 3x equals 3y, which equals z. So I'm just going to say x equals y and z is 1. So 3x equals 1/3 of z. Wait, yes, so 3x. Or I'm sorry, x equals 1/3 of z. So z is equal to 3x. I'm just going to do that. So this is 1/2 times 3x. And this is just x. This is the same. So w is equal to 5x, let's say. And then add all of these up. So 1/3 x plus 1/2 x plus 3x x. And that's going to equal 2/6 plus 3/6 plus 9/6. 2 plus 2 plus 9, 14/6 x. So that's 7/3 x. And then 5 equals what times 7/3? Be 15/7. I hope that's an answer. No, it's not. But oh yeah, oh, because I reversed it. 7/15. Cool. All right. Last page. How am I doing on time? Great. Love it. Box contains exactly 7 fuses, 3 of which are defective and 4 of which are not defective. In the bar graph above, let me just draw this box. Can't use those. And then these ones are okay. In the bar graph above, left and middle bars are the same height. Right bar is half this height. Heights are intended to represent effectively the probability of obtaining 0 defective fuses, exactly 1 defective fuse, 2 defective fuses when 2 fuses are randomly selected without replacement. However, one of the bar heights is incorrect. Correct height is k times the height shown. So the following choices bar and the value of k would result in an accurate represent. Oh, interesting. Okay. So the probability of obtaining 0 defective fuses. So we need to, it's 4 out of 7 times 3 out of 6 times 2 out of 5. But then so the trick is going to be to not calculate this. So this is 0. And then exactly 1 is going to be 4/7 times 3 out of 6, but then times 3 out of 5, but then times 3. Is it, or is it 3 factorial? Because it can come in any order. Maybe it's times 2 factorial. And then 2 is going to be 4/7 times 3 out of 6 times 2 out of 5 times also 3 factorial. Okay, so basically, I don't care about that. I care about what remains. So this is 2/5 versus 6 or 18/5 versus 12/5. Oh, but oh yeah. Well, it's either the left. Yeah, I don't care anymore. This problem sucks. I think left bar k equals 2. Right? Because it's way more likely that or k equals 1/2. It's way more likely that I'm going to get 1 defective fuse. Right? I mean, unless it's like the middle bar. No, well, yeah, but it can't be the middle. Oh, I should have checked the answer choices. Okay, yeah, we can estimate this. Let's start over. Let's estimate. It's way more. It's way more likely that we're going to get 1 defective fuse, right? Like we got to get really lucky to get 0. And then it's fairly likely that we're going to get 2 defective fuses. But I think it's more likely that we're going to get 1, right? We'd have to have really bad luck to get 2 defective ones. So I'm going to go with, yeah, left bar k equals 1/2 seems kind of okay. I'm not sure that's right, but like that, yeah, that's a good enough guess. Fine. Cost of a mixture that contains candy-coated chocolate pieces. See, I had all this time, and I thought I was going to be cool and solve that problem, but I shouldn't have tried. Cost of a mixture that contains candy-coated chocolate pieces and salted peanuts in the ratio of 2 pounds of chocolate to 3 pounds of peanuts is $3.80 per pound. Is this a weighted average problem? Maybe. Well, let's do it as an unknown multiplier. So chocolate and salted peanuts. Let's call it 2x and 3x. And the total cost is 380 times 5, right? Because we're buying. Oh, wait. But that's just the ratio, so we don't know that. Oh, but we do know that yeah, we do kind of know that the total cost is, it's 38 times 5. That would be $19, right? So 19x per 5 pounds, I think. So the chocolate pieces cost $2 more per pound than the peanuts. Hold on. I feel like I'm missing something. Let me just read it. Oh, okay. So let's divide this in 2. So that would be 190. So the chocolate pieces is like 290, and the salted peanuts is 90 per pound. Okay. We can go back to this. I'll explain how I got that. But how much the peanuts cost per pound? Oh, wait, that's all I need, 90 cents per pound. Shoot, yeah, I was missing something. All right. We'll rewrite a quadratic equation into this form. John and Katie both made arrows. Oh. Interesting. Okay. So we know that ax squared plus bx plus something other than c is equal to. Oh, no, I should work backwards here. Right? Yeah. So the correct solutions. Oh, wait. No, I don't. I just don't want to do this. I'm sorry. Well, what are some likely solutions to a quadratic equation? I think I know. So if you mess up the positive and negative, that's going to screw up C, right? And then 7, so I bet it's -6 and -2. That's kind of a wild guess, but it's my best guess. The value of √8 plus √9. Oh, so this is just a grinded out problem. Yeah, so we got to expand this, but that's not going to be terrible. So 8 factorial plus 2 root 8 factorial root 9 factorial plus 9 factorial. Oops, 9 factorial is an integer. And if we simplify that, we're going to get 8 factorial plus 2 root 8 factorial. And then 9 factorial is going to be root 8 factorial times root 9. So that's root 8 factorial times 3 plus 9 factorial. I'm doing a little fancy math footwork here, but that's going to be 8 factorial plus 3, I'm sorry, plus 3 times 2 would be 6 times 8 factorial plus 9 factorial. That's going to be 7 times 8 factorial plus 9 factorial, which, by the way, is 9 times 8 factorial. So that would be 16 times 8 factorial. So what is the greatest integer n such that 2 to the n is, ooh, tricky. Man, this is a hard problem. Okay, so what we got to do is prime factorialize 8 factorial. So that's 8, 7, 6, 5, 4, 3, 2, 1. How many 2's are in there? 1, 2, 3. 2, 3, and 4. And then 5, 6, 7, and then we've got 16. So 1, 8, 9, 10, 11. So 11 is the answer. Ooh, sneaky. All right. Next, you completed a response. Yes. All right. So I'm going to go back to 4, 9, and 14 because the other ones that I skipped were just ridiculous. Let me clear my scratch paper. 4, 9, and 14. And let's just see what I can do. Oh, I could have bookmarked them. I should have bookmarked them, guys. If this happens to you, bookmark the ones that you want to come back to. Which the following is equal to root 6 minus root 2. Oh, this one. Yeah, okay. So I tried to estimate earlier, but that didn't work because these answer choices were too close together. So I need an actual solution here. I think I had the right strategy. I think I just did my math wrong. So let's try and rationalize this denominator. Root 6 minus root 2 squared is going to be, let me just, I'll do it in one step. It's going to be 6 minus 2 root 6 root 2 plus 2 over, and then I'm going to difference the squares this. So that's 6 minus 2. If that doesn't make any sense, think about what I did before. We can go over this later, but that's going to be 8 minus 2 root 6 root 2 is root 12 over 4. Oh, I know what I screwed up earlier. That was a times or something. Yeah, oh God. That's 2 minus root 12. And I have to do more math. Yeah, I do. That's 2 minus root 12 is 2 root 3. Oh, okay. And now I can factor out. That's 1 minus root 3. But why isn't that an answer choice? Why? Why are you doing this to me? What did I screw up? I feel like I still probably have the right answer, but let me just see if I can find my mistake. 8 minus, oh, over 4. Oh, yeah. I do have the right answer. Let me just verify that. So that would be 2 minus 1/2 of root 12. Yeah. So that would be 2 minus, I did have the right answer. Oh, that's cool though. So I don't have to change it. Nice. Okay, back to Review Center. That means that's an extra one I can steal that I could change if I wanted to. Oh God, this problem. Let me do 14. I think I have a better shot at that. Yeah. Okay. Peru bought various numbers of 5 types of school supplies. Okay, so yeah, let's just do this. Let's just say, let's say one costs $60. Sorry, my scratch paper is getting ugly. I have to bear with me. That means that if we're doing buy one, get one at 50% off, that means that 2 would be $90. That means that 3 would be 100. Oh, wait, no. 3 would be 90 plus 60 is $150. But then 4, that next one is half off, right? So that would be $180. I picked a weird number to start with. I'll explain why. That's a mistake, but I'll explain why I did that maybe later on. But then 5 would be 240. 6 would be 270, etc. So let's just see which one is being described here. 4 markers for the price of 3. So if 1 is $60, then the price, actually, I think it's markers. So let me just verify that. 3 pens for the price of 2. No, because 3 would be $150. Yeah, so I had this wrong. I think it's markers. I'm changing it. And how do I verify that? Yeah, confirm and return to review center. Do you want to change your answer to this question? Yeah, you betcha. I'm stealing points. Let's go. What else did I want to return to? I think, I think probably now number 9, because the other 2 were just brutal that I skipped. So this one's pretty bad. I think 2 minutes is going to do it for me, but let's see what I can do. Number line which following specifies a set of all numbers such that, well, can we just check like 2, 3, and what would be good to check actually? How about like 2 and 5 right off the bat? I think those are going to get rid of a lot of answer choices. So if x equals 2, if x equals 5, 2 minus 3 absolute value is 1, plus 2 minus 4 absolute value is 2. Is that less than 2? No. So this should be outside of the range. A, B, C, D, E. What does that get rid of? Gets rid of A and B, and that's it. Actually, so x equals 5 won't matter. Let's do something else. Let's do x equals 4.5. Okay, so 4.5 minus 3 absolute value is 1.5, plus 0.5. Is that less than 2? No, it is not. So 4.5 should not be in the range. But yeah, since that's right on target, I think I actually had the correct answer. So pretty happy. And before it runs out of time, I have to guess my score. I don't have time to correct anymore. So I'm gonna guess, Stacey, that I got a 685, because I think I salvaged a little bit of points with this quant and with the verbal last time. But
all right. So data insights definitely was the section where you were like, okay, that sucked.
Yeah.
But the other ones we're not too bad.
Oh, it's hiding it. Okay, so before we can do a big reveal.
Oh, look at that. Okay.
I can't actually see it.
You'll run out of time.
Yeah. Yeah, so should I reveal it or anything you want to ask me before that?
Does anyone else want to, was anyone here for all 3? Does anyone else want to guess? Do you want to say anything else, Ryan, before you see the score?
Yeah, so I want to say that I don't actually really fully understand how this score is going to come out with 2 good sections and 1 bad section, because on the old classic GMAT, it was just 2 sections, so I had a much better idea of how things balanced. So I'm really curious to see what's going to happen. I also don't think data insights was like that awful. You know, I mean, I think I got enough right kind of at the end that maybe I salvaged it a little bit. So that's something I'm also not sure about, is how well I managed to guess on that section.
Right. Totally go look.
Yeah, we'll see.
Okay, and then the other thing I'm going to do is I've just been making slides of screenshots of all of your Scratch work. I'm going to email that to you because you're going to continue to share screen as you show this, but then you can also pull up your Scratch work if you want to go back to show us anything from your Scratch work, or if you just want to look at it yourself.
Yeah.
All right, drum roll. I can't do it, whatever.
We're ready?
Let's do it.
Let's see. 6:15.
Oh man. It was the data insights section.
I got rocked on data insights.
Yeah.
Oh, Quant wasn't as good as I thought it was going to be, though. Interesting.
All right. There were a couple of, well, you found one careless mistake. There were a couple of other spots. Let's go take a look. Hold on. Let me email this to you. Okay. So Ryan.
6:15. That's rough.
Yeah, it was really, if you look at the scores there, it was data insights that did you in. That was you spent 15 minutes on 3 questions. I'm sorry. Or like, okay, hold on, let me send this to you. And you can just go ahead too and go into the score report and start looking at, start with the quant section. Okay. For that very last one that you went back to, I forgot to notice which question number it was. So I just put that scratch work at the very end of the deck that I just sent to you. But everything else in the deck is in order. And for the ones that you went back to, the scratch work is on like the next page from when you originally did that one.
Cool.
Okay, so if you click on the quantitative reasoning section, so then this shows you, it gives you data basically, and it shows you your just for everyone looking at this, it shows you basically the question. So if you look at this, Ryan was 100% through question 12, and then started getting, since he got all those questions right, started getting some really brutal questions.
Yeah, man, what happened?
You got to just well, let's go through them all. So let's start at the beginning and go through, because I also want to see if anyone has questions about how you answered any of these, even the ones that
you want to go through the correct ones as well.
Yeah, because people might have questions about how you did them.
All right.
So what we're going to do, everybody, is Ryan's going to scroll through. If he's got anything to say, or if I've got anything to say, we'll say it. But please also just let us know in the chat anything that you particularly want to know or questions you have about any of this. And I'm just looking at the Q&A stuff as well. So let's a couple questions, big picture questions that people asked in the Q&A. This recording will be posted on our YouTube channel. The first 2 recordings are already there for the first 2 sections that Ryan did. And the idea for this session basically is Ryan's just taking it to, someone's asking, what is the Twitch session? So Ryan's taking the test live, as you just saw. And now we're talking about it. Is this practice test question adaptive? Yes, this is the official practice test that is made by the test makers. And so it's running on the same algorithm that the official test does, which means indeed, as you get questions right, you're getting harder questions, or as you're missing questions, you're getting easier questions. And Ryan is indeed a staff member at Manhattan Prep. He's one of our instructors, as am I. Okay, so big picture questions. Any questions on this problem? Ryan, anything you want to say about this problem?
No, straightforward algebra.
Anybody have questions about this one? From what I remember of what you did on your scratch work, you wrote out all the steps. So it was pretty,
yeah,
like, you laid it all out. There were a couple later on, by the way, where you were going so fast that I was like, ooh, people are going to want to know how you really did that, because you started like doing some stuff in your head. But this one, yeah, you laid out the work. So I think we're good to go to the next one.
Okay. Go.
All right, this rate problem. Anybody have questions about how Ryan got to 7.5 on this one? Yes, we've got multiple hands raised on this one. If you've got specific questions on it, toss those questions in the chat and Ryan can take us through the work right now.
I'll start by saying that I've seen a lot of these problems before. And the key is that we know, so here's what we know, right? We know they're mowing 1 yard and we know they're doing it in 5 hours, sharing alone, and 3 hours when they work together. So
And
the key is,
I'll just mention, so the reason Ryan put 1 for the yards, it's not like the number of yards that they're mowing or something like that. It's the actual yard, the garden, the whatever. And when you have, this is called a work problem, like they're doing a job and the job is to mow the yard. So whenever you have that, the job is just always 1. The work to be done is to finish the job. So just call that 1.
Yeah. And so then you can solve for the rate, right? Because rate is always the work over the time. So that's 1/5 and 1/3. And then the key to these problems when people work together is that 1/5 plus whatever Rumla's rate is going to equal 1/3. When people work together, you can add their rates to get the combined rate.
So for example, if Ryan and I could each do 1/5 of the yard per hour, then if we work together for an hour, we're going to do 2/5 of the yard.
Yeah. So
and the work that you did there too, Ryan, to figure out what that fraction is for. Oh no, sorry, I'm thinking of a different problem. No, keep going.
Yeah, so I just basically subtracted what's 1/3 minus 1/5. That would be 2/15. So 2/15 times the answer should equal 1. So that has to be 15 halves.
And someone's asking in the chat, can you add rates with RTD problems? So yes, as long as so you would add rates when the 2 people or machines or whatever it is are working together towards the same goal. So on a work problem, they're both working to, mow the lawn or whatever. On a rate problem, it would be something like they're both working to come closer together. Like I'm here and Ryan's here and he's coming towards me at 3 miles an hour and I'm going towards him at 2 miles an hour. You can add those rates because we're both contributing to the same goal of getting closer together. Or if we were starting in the same location and we were going away from each other, you could add those rates because we're both working towards the same goal of moving away from each other. It would be different if like we both started in the same place and we were both going in the same direction, but at different speeds. We're now like competing with each other. And so it doesn't work then. But if the 2 things are coming towards each other, directly towards each other, or moving directly away from each other, you can just add the rates. Other questions on rate and work stuff? Anything? All right, I'm going to lower hands for this question. Let's go to the next one.
It's me.
Yeah. You're used to me doing this for you. All right. And so this one was when Ryan did that tree to figure out how many people were in each of these groups. And notice how careful he was about reading it. Ryan, I wanted to, and like writing out and separating this out, super careful, because that's the trick to these problems is like, which group are they talking about now? Every time they give me a new number or want me to take a new calculation or whatever, which group are they talking about now?
Yeah.
So with each new piece of information, he had to just keep moving down to some different part of the tree.
Yeah, and I will say the easiest way to get these problems wrong is to just read this as 50% of everybody instead of 50% of the remaining physicals.
Yeah.
So,
yeah. Any questions on this one? Anything you want to talk about? Let us know in the chat any questions you have about it. And he's just recreating his work. And there might have been a question at the very end about how you jump, right? So that part's all laid out.
oh,
And then at the end, they asked about US to European. So the US is 80, the European is 5. And so basically the question there is, what do you need to multiply 5 by to get to 80?
Yeah.
The how many times, like basically how many times was X of Y is like, okay, what do I need to multiply this smaller number by to get the larger number? So for that, you can also, you don't necessarily have to have that memorized, the multiplication. You can kind of look at to multiply 5 times 80, it's certainly more than 10. So answers A, B, and C are gone. but it's not as much as 30. 5 times 30 is 150. So it can't be E either. So it must be 16, which is the only answer left.
Next one.
Anything else on this one that you want to talk about? Okay, I'm going to lower hands again. What's our next one? Oh, this thing.
Oh, yeah, this one we spent a lot of time on. But
Do you want to pull up your work from the first? Because I'll show you where you made your careless mistake.
Oh, I haven't downloaded it, but you can just. Okay. Did I do like some time like multiply instead of minus?
You multiplied instead of yes.
Yeah, yeah.
Exactly.
It's funny, like I remembered it all like 20 minutes later, but yeah. I should explain. So this is a rationalize the denominator problem. And sometimes it's going to be easy. So if they ask you something like what's 10 over the square root of 2, what you just do is you multiply by a fancy form of 1, right? So like root 2 over root 2. And that gets you 10 root 2 up top, but root 2 times root 2 is 2. And so what you've accomplished by doing this is moving the square root from the denominator to the numerator, right? That's what you want. That's why they call it rationalizing the denominator.
And Ryan, how did you know that this was what you needed to do to get the answer on this one?
Yeah, so it's just because like when I see square roots in the denominator, I know that math nerds don't like that. And so I know that I'm going to have to like
Also, though, what was the definitive clue on screen that told you that you had to be that?
Well, the answer choices too.
The answer choices.
Yeah. So I mean, I'll be honest, that's not how I knew, but it's probably how everybody else should know.
That's how you confirm it. So if you glance at the answers, you can see that in the original fraction at top, there's a square root sign in the denominator, but none of the answers has a square root in the denominator. So you got to get rid of the square root in the denominator if you're going to solve this thing.
Yeah. And so the way to do that when you have two irrational terms is you multiply by something that's going to create a difference of squares.
And sorry, be careful about the way that you wrote that because it's not matching what's up above.
It's not?
Because it's got to have one square root sign all the way across.
That's
square root 6 minus square root 2 is, oh, sorry. On my screen, it's so tiny, I can't see. You're good, sorry.
Yeah.
I'm seeing I can't see the difference fraction
bar. I don't want to screw it up a second time.
You're good. It's so tiny on my screen that the fraction bar and the top of the square root thing look like one line.
Yeah. So what we have to do is multiply by 1, right? So same thing on top and bottom. But notice on bottom we have a difference of squares. And the cool thing about the difference of squares is it gets rid of that middle term, the 2 root 6 root 2 thing that you normally get, when you do the thing up top. So that's why on the bottom of the fraction, you're just going to get 6 minus 2, because I'm using that, a plus b times a minus b is equal to a squared minus b squared.
And that's one of the 3 common quadratic equations that you want to have memorized for this test.
Yeah. So I think it should be fairly doable from there. I mean, this you can just FOIL it out. You're going to get it out. Yeah, you're going to get 6.
And then simplify down. Yeah, and so that your mistake there was when you simplified down that 6 that's out front, you did it as 2 times instead of 2 minus.
Yeah. So there we go.
Because your scratch paper you were running out of room on your scratch paper.
Yeah. But once you get here, it should be okay. So let me know if there are questions about it.
Thoughts, questions, anything on that one? All right, let's try the next one.
Oh, yeah. This one was interesting. I should explain a little bit. So if x is a multiple of 18, that means it has 2, 3, 3 in the prime tree and maybe some other stuff, right?
Because we don't know everything that x is a multiple of.
Yeah. So,
sorry, reverse that sentence, but yes.
Yeah. So if it's like maybe x is equal to 90, right? And then it would be 2, 3, 3, 5 or whatever. And then if x is a multiple of 60, it's definitely got a 2. What is 60? That's 12 times 5, right? So 2, and then 2, and then 3, and then 5, and then maybe some other stuff. So
But the key here, which Ryan, you knew and you did it, but you didn't like say it in the middle because you were taking the test, is that you can have overlap between these two groups.
Yeah.
So like that 2 that's sitting under the 18 could be the same 2 that's sitting under the 60. So it doesn't necessarily mean you have 3 2s.
Yeah. Yeah.
You
And I'll
might
give you an example of that too. Like if you think about the number 180, that's a multiple of 18. It's also a multiple of 60. But notice it still only has, I believe, 2 2s in the prime tree, right? Because the prime tree here would be 2, 2, 3, 3, 5. So it's got everything that 18 has, right? I see a 2, a 3, and a 3. It's got everything that 60 has. It's got 2, 2, 3, 5, right? Plus an extra 3. And yet it doesn't have all of these combined, right? Like I don't see 2, 2, 2, 3, 3, 3, 5, which is what happens if I, actually like mush these prime trees together. So yeah, that's important, is that like you can have, you don't have to have every single thing here. You just need to have the maximum number of what anything has, which in this case is 2 2s, 2 3s, and a 5. So, and I guess that means 180 is the smallest possible multiple of both of these. So this is what it's going to have. And then I just had to check these 3 numbers, for are all of these things included in 24 and 36 and 45? And 36, yes, and 45, yes. But 24 is 2 times 2 times 2 times 3, and we didn't have that third 2. So that's why I said no for this one. So yeah, sneaky prime tree problem. And I think I messed up 36. I misread it as 32 when I made that mistake. But once I figured that out, it's okay.
Any other questions on this one? And to the person who is asking questions about multiples, and if you want to learn more about multiples, you can take a look at our Foundations of Math ebook. It's available for free on Amazon. You can just go download it. And it will tell you everything you ever wanted to know and probably a little bit more about multiples and how they're tested on the GMAT.
Oh, this one. Yeah, this one was more about just the way what they were asking, because it basically said Eric invested $10,000 and eventually he ended up with double that, right? That's part of the key to this problem, is that 20,000 is double what you started with, and then 40,000 is double that. And we also knew that this is 8% compounding interest, or compounded annually, I should say. And this is 12% interest. And so this rule says that the number of years that it takes to double is just 72 divided by the interest rate. So this takes 72 over 8 years. And this takes 72 over 12 years. So that's how I did that one. So you just do the math. Get 9 years, 6 years, 15. I think this is also one of those where they're trying to get your brain to fry, right? They're trying to confuse you with just.
Well, they're introducing this new thing, and then you're panicking because you're like, wait, I didn't study this. What is this? I don't know what this rule of 72 thing is. They will sometimes introduce new rules, new formulas thing. This isn't something they made up, this particular one, but sometimes they will introduce something they've completely made up, some weird definition of something. And it's basically comprehension, which is most of this test is about. Can you read what I'm telling you and think about it and understand it and then do something with it?
Go on to the next one. Oh, yeah. Okay, so this one, I've seen stuff like this before. Whenever you have 4s and 5s, when you get it down to 2 to the something times 5 to the 17, that's going to create a lot of 10s because 2 times 5 happens to equal 10. So when they start asking you about numbers of digits or something like that, that's one way to think about it. The other thing is anytime you have 4 to the something or 8 to the something or 16 to the something, just, I can smell the rat. I know it's probably going to be like a power of 2 question. So I think like recognizing these numbers just on site, 4, 8, and 16, that's kind of an important thing on GMAT. So yeah, once you realize 4 to the 9th is just 2 squared to the 9th, and that equals 2 to the 18th. Then you're good. You can split it into 2 to the 1st times 2 to the 17th times 5 to the 17th. So that is 2 times 10 to the 17th.
Please do not write that out during the test.
It's got 18 digits.
Not a good use of your time during the test.
No.
What else?
Get on this one. Let's see. Oh yeah, this I was a little hesitant to actually just like do the brute force math here. So we had 45 for food, 90 for clothing. And I was like, this calculation here is not so awful that I don't mind just doing it just in case. I didn't actually know when I did the calculation that it was going to be necessary, but I kind of suspected. So 210 minus 90 is 120, minus 45 is 75. And then, yeah, I could kind of see, okay, they're asking for the total tax. So I did the actual math. Now, I should mention I'm benchmarking percents here. So this is a kind of an important skill here. To do 2% on clothing, I do 1% and then I double it, right? So 1% of 90 would be 90 cents. Double that would be $1.80. And I think that is kind of important to be able to do that calculation quickly in your head. Same with 6%. There's a trick here. So 6% is 75. I'm doing 1%, which is 75 cents. And then to do times 6, I actually do times 2 and then times 3. So 75 cents times 2 would be $1.50, times 3 would be $4.50. So now you add those up, you get $6.30.
The other thing on this one, so I probably would not have brute forced this one myself because I hate brute forcing anything because I'm not as good at math as Ryan is. This one is essentially a weighted average.
Oh,
I'm paying 0% on food, I'm paying 2% on sales tax, and I'm paying 6% on everything else. And so what's the weighted average essentially of the stuff that I'm buying, because that determines the overall percentage I'm going to end up paying. So you could approach this in a weighted average, from a weighted average standpoint as well.
That's clever. Yeah.
Just a thought. What's next?
Oh yeah. Well, this one you've seen enough of. But
So yes, he went back to this one and figured it out.
Can you think of
make a little bit of a guess at the end there. You didn't figure out between 2.5 to 4 and 4.5 and 3 and 4 because you're running.
I mean, I could have tested like 4.25.
You could have tested 4 itself, right? You could have just tested 4.
Oh, that's true.
Yeah, 4 is not included in answer E, but it is included in answer D. You were running out of time at that point, so you didn't really have time. So it was a good call to go with what you did, but that would have been the next step if you had time, right? Was just test 4.
Let's go to the next one. Oh yeah, this one is a weighted average. So man, the weighted average stuff saves you a ton of time if you can practice these problems. So basically the deal is if it's all 8% versus if it's all 3%, then I could just say, this is, all 300 tons are this, right? Or all 300 tons are this. But since we want it to be 6%, that is 3/5. This is a distance, or this is a fraction of 3/5 of the total, and this is a fraction of 2/5. These lengths here. That's one way to think about it. And so if we're closer to the all 8% mixture, that means more than half of our mixture is 8%, right? That's got to be the 3/5. So I just did 3/5 times 300 tons. And that's one.
And someone's asking about the difference between, oh, sorry, are you done, Ryan?
Yeah.
Okay. Someone's asking about the difference between regular average and weighted average. So a regular average is basically the two things that you're taking the average of. They're equally weighted. There's the same amount of both in the calculation that you're doing. So for example, let's say that you're, taking a class and you have two tests that are going to go into your grade for that class. You've got your midterm exam and you've got your final exam. And each of those two exams is going to be weighted equally. So then you can just say, okay, I get 95 on my midterm exam and I get 92 on my final exam. And I can just average those two numbers to find out what my overall average is for the class. But let's say instead, as was really common, at least when I was in school, a lot of times they would weight the final exam more heavily than the midterm exam. So maybe the midterm exam is only going to be 40% of your grade and the final exam is going to be 60% of your grade. And now all of a sudden the calculation gets more complicated. You can't just take a regular average of the two numbers. You have to do some more manipulation like Ryan was doing here in order to figure out what the weighted average is.
Okay, yeah, this one I've kind of seen before. There was an old edition of the official guide that had a problem very similar to this, where we're not really finding what S is. We're finding the extreme maximum of what S could be versus the extreme minimum of what S could be. So when you think about what this can be, I think I wrote these out, right? Plus 1 over 64.
And before you keep going, I'm just going to say, he has 2 minutes and he doesn't have a calculator. So obviously nobody on the planet is going to actually add that up in 2 minutes without a calculator. So when you see something like that, where the math is clearly impossible to be done without I couldn't even do that with a calculator, or without a calculator at all, no matter how much time you gave me. So they give you something where the math is clearly impossible. The issue is not, how do I do this crazy math? The issue is there's a pattern somehow. So I need to figure out I need to see whether I can figure out what the pattern is. If I can figure out the pattern, I have a chance to solve this thing. If I can't figure out the pattern, I guess I move on.
So the trick here is that this actual sequence here is bigger than this top thing, and it's got to be smaller than this bottom thing. And that's because each term is bigger than each term in the top thing, right? Each term in S. And each term in S is smaller than each term in the bottom thing.
And did you mean to write 33 on the bottom?
No. Because there are 32 numbers, it's way easier. I think there are 32 numbers in the sequence, right? From 33 to 64.
64 minus 33 plus 1. I don't know.
Yeah, so the sum of these is 32 over 32. The sum of these is 32 over 64.
Okay.
Yeah, so this is equal to 1. This is equal to 1/2. So S must be somewhere in between those. The other way to do this, by the way, is to just estimate. You could just say, what's roughly in the middle? That would, like 1 over 44. So you can just say, well, S is about 32 over 34, or 44. I don't know what that is, but I do know it's in this range. So it's a rough estimate.
Nice.
And then this is where I started getting things wrong. So let's see. Oh, wait, how can it be negative?
So when it can't, that last answer choice says positive. You just missed it when you read it.
Oh.
It says all positive real numbers less than or equal to 1.
Oh yeah, oh God, oh that annoys me. So the reasoning was right, and
Yeah, your reasoning was totally right. You just misread that
pick
last
the wrong
answer in the franticness of it.
Okay. So well, okay, then I
So
at
what's
least
the difference? And by the way, everybody, what's the difference between answer D and answer E? Ryan, don't answer this. I know you'll read it and get it, but everyone else in the room, what's the difference between answer D and answer E?
so annoyed by this.
Yes, Allison's got it. Answer D includes 0, greater than or equal to 0. So between 0 and 1, but including 0 and including 1. Where answer E does not include 0. So it's got to be only the positive ones that are less than or equal to 1. So it's almost exactly the same range, except D includes 0 and E does not include 0.
I'm very annoyed by this. Can we not look at it anymore?
Keep going.
Moving on. Oh, this one was kind of fun. Yeah, so I've seen a variation of this problem where they're like, these people have one license, this number of people has 2 licenses, and this number of people has 3 licenses. This one is actually slightly simpler than that variant, which made it kind of nice. So I didn't have to do a whole bunch of algebra. What I basically did is I said 10 plus 11 plus 13 is the number of licenses given out. But because there's some number of lawyers that are triple threats that account for those 34 licenses, each of those lawyers accounts for 3 of those licenses. So I said if there are 28 lawyers, the difference between this and this is 6. So I've got to do like -3 but +9, right? Because -3 because they don't have single licenses, but +9 because they have triple licenses. I know that's kind of a weird way of thinking about it, but that's the best I got. So
I'll give you a way that might be slightly easier.
oh, what's that?
If you have 3 licenses, then you have 2 extra licenses compared to everybody else.
Oh, that's
so the first, like the 28 lawyers, everybody has at least 1 license. There's our 28, right? And then if you're a triple threat, you have 2 extra licenses. So each one person who is a triple threat accounts for 2 extra licenses. And since there's 6 extra licenses, there must be 3 people each with 2 extra licenses.
Yep. So that means there are 3 triple threats out of the 28. And because all of those triple threats, by definition, must be licensed in state C because they're licensed in all states, that means it's 3 and 10. So there you go. I'm surprised they didn't give 13 as an answer choice.
Yeah, they
Maybe
should have.
because it's in the problem. I don't. Cool. Oh yeah, this one we've gone through, but I'm glad I went back to this one. Because like I don't know what I was doing the first time, but it wasn't right. I will be honest, I think like the way that I did this problem the second time around is probably the way to do it, which is just to like pick a number and then see how much would 1 thing, 2 things, 3 things, 4 things, 5 things, and 6 things cost. I'm sure there is a way to do it algebraically, but it seems like more trouble than it's worth. And because you'd have to do like each thing as a separate thing. So I don't know. I shouldn't have picked $60. I picked that because it's divisible by a lot of things, but like that wasn't necessary. So you could have just as easily done, I don't know, like probably $10 or something, I think. I don't know. Maybe 60 was a good pick. Whatever. It worked out.
Yeah, for stories like this, I really like to first of all, I avoid algebra like the plague because again, you can't tell when you set up algebra incorrectly, right? If you make a mistake in the setup of the algebra, you're going to think you're fine and you're going to keep going. And the only way you'll know is when you you get an answer that's not in the answer choices. So for anytime I can do this, but in particular for stories, if I can kind of just make it real world and be like, okay, if I were sitting in a meeting right now and somebody asked me to figure this out, I wouldn't start writing algebra. I just start kind of mapping it out and trying to like, make some scenarios and see what happens. So anytime you can do that, if you can train yourself to do that and get good practice with it, it's going to help you not just on this test, but also at work and in B school and in actual real life situations.
Oh God, I have no idea how to do this problem. Do you, Stacey?
No, I'm annoyed that it still include coordinate plane on the test, because this does still annoyingly fit into what they've said the test covers, because this is a coordinate plane problem.
Yeah.
We're going to have to ask somebody else how to actually do this one effectively.
Yeah.
I liked your idea of how to figure out a pattern, but then like you, I was like, okay, now that I want to draw a fourth circle in here, how am I going to possibly do that in a way that I'm going to see what the pattern is? My guess is that there's some combinatoricsy type thing going on here, which I also hate. So this was an excellent one to guess on. Anybody in the room? Anybody else have ideas about that one?
Yeah, does anybody know how to do this? Going once, going twice. Okay.
This is, by the way, so coordinate plane is still allowed to be tested on the test. So far from reports of, so first of all, from the practice tests that we've seen and from reports of our teachers who've gone in to take the official test already, it's unlikely to see more than one on a test. And so if you hate coordinate plane, feel free to just not study it and just assume that you're going to guess if you see one. It's fun.
And now that I'm looking at this question, I'm so annoyed that I missed it, because I had the strategy right. I just made a silly mistake.
Yeah, you were shortcutting your work kind of on this one. I think you were feeling the time pressure a little bit.
Yeah, which is weird because I did.
You
yeah,
didn't.
I mean,
I don't know why you did shortcut the work on this one. I have in my notes.
I was feeling excited because I found something that I knew how to do. And I think I was a little too excited about that. So
I have in my notes that I was going to make you redo the work here to show everybody how you really did it, because you were like massively shortcutting it as you went.
Yeah. So let me do it for real. We've got a difference of squares. This is...
So, and this is again, one of those three common quadratics that you want to have memorized for the test. So if the outcome is a squared minus b squared, then the other form of that is to put it in these parentheses with the plus and minus thing going on.
Yeah.
And now what is a super annoying number with 99999 turns into a slightly less annoying.
Yeah. And the mistake I made, by the way, was I just left off a 0. Now I'm mad about it. So 10 to the 5th.
At that one, you didn't write out that second one. You wrote it down as 9998. Yeah. So that's the other thing on this test that Ryan and I have both learned the hard way, which is write out all your work. Write it out every time.
What is it that they say about dress rehearsals? When you have a terrible dress rehearsal, you're going to have a great opening night. I'm hoping that that's the case for me. You guys know I have to take the real GMAT at sometime soon, because I have not yet taken the official GMAT Focus, like in the test center and everything. So I'm kind of treating this like a dress rehearsal. And I am learning some things, like write out your full work, especially when I do difference of squares, because that other difference of squares problem too, like slowed me down a little bit. So, I should just take my time, write out all the steps. Okay. This one, I actually kind of guessed because I got 15/7, but I think I did this one correctly. I don't know. Do people have questions about this one? It's kind of a weird one.
I did kind of wonder why you didn't just plug in a value.
Oh, well, I sort of did. Yeah, I sort of did. I mean,
you started substituting in and being like, oh, so this is X and then 3X. And I was like, why not just call it 1 minute, 1 minute, 3 minutes?
That would have been a good idea.
Why the other thing is on this one. The other thing is on this one, then you went to go add 3 fractions, and your 3 fractions that you were adding were 1/3, 1/2, and 3/2.
Wow.
You could have, and you found common denominator for the whole thing. You could have just said, well, 1/2 plus 3/2 is 2, and then you still have a third, so it's 2 1/3.
Oh, yeah.
So, but lesson there too is when you have to do anything where you have to like add fractions or do anything where it's like multiple steps, pause for a second and look at the whole thing before you start and see if there's a way to like group the, rearrange the order in which you're doing the math or anything like that to make it easier.
Yeah, paper smart numbers would be good.
Oh yeah, this one.
Yeah, okay, so I'm okay with this because I made a reasonable guess. So basically, I got to the point where I'm like, this number one is going to be the most likely. Right.
You second guessed yourself as you went though. You
Did
were
I?
you were going to choose C or D, or sorry, no, you ended up choosing E. You were second guessing yourself as you went a little bit on this one.
Huh. Because I thought what was going to happen was this would be the or like 0 and 2 would be kind of the least likely. And so I picked, in retrospect, if I had thought about this a little more, I get why B is the answer, because I should not have picked an answer choice that resulted in an equal number for these. I'm realizing that now as I'm drawing out my guess. I figured that number one would be the most likely. And so I was just like, oh, we need to drag this bar on the left downward. So that's why I guess left bar k equals 1/2. But now in retrospect, I realize that that would make that bar equal to this 2 bar over here. And that seems unlikely that 2 bars would be exactly equal, because this does seem like a weird combinatorics-y thing where they're all going to have different probabilities.
Yeah, well, because it's 7 fuses, 3 defective, 4 not defective. So
yeah,
that's going to result in funky numbers.
Yeah, so looking at it again, the correct answer would result in bars that look like this, where 1 is all the way up here, 2, or I'm sorry, 0 is half of that, but then 2 would be like this small. And that actually does seem more like a real world what would happen. I do think that estimating is the way to go here, by the way.
So let's go back and do this one now, right? Like we know what the answer is now, but let's go back and like, how would you actually do this one knowing what you know now?
You mean like math wise or estimation wise?
Either way, whatever you think is the best approach. So if
estimation is the way to go, because the combinatorics I think gets awful. So I think you'd have to estimate, and I would basically have to say also in thinking about it, I think it's really unlikely that you're going to pick 2 defective fuses, right? Because there are only 3 in the box. You'd have to get really unlucky. I think it's more likely that you're going to pick 0 defective fuses because there are more of those in the box. You know what I mean? Or there are more of the working fuses in the box. Fuses. Yeah.
There's 4 that work and 3 that don't. So you'd be more likely to have things to get 2 that work than 2 that don't work.
Yeah, so I mean, I think the key is to just think like a poker player, right? You're never going to calculate the exact odds, but you can have some sense of what the odds are, and like that's got to be good enough on this problem. I can't imagine there's any way you could do the combinatorics.
So if you start with that idea, right? So 3 don't work. 3 fuses don't work, 4 fuses work. That little graph is showing that the probability of getting 0 and 1 is the same, of having them both work versus having only 1 work is the same, but that doesn't really make sense, because you have to get luckier essentially to get 2 that work than to get just 1 that works. So 0 and 1, like 0 and 1 shouldn't actually be the same. And then it does make sense that 2 defective fuses is the lowest one, because that's the one where you have 3 that are defective, like you have fewer that are defective than that work. So that can kind of lean you towards, okay, it's got to be 0 or 1 that needs to be fixed. And then what you said, Ryan, you were like, oh, I should have looked at the answer choices. But at the end of it, you're like, oh, I should have just tested the answer choices. So that like overall logical reasoning knocks out answer choice E. It's not going to be the right bar that changes. It should be the case that the least likely scenario is that you get 2 defective fuses. So that's fine. Leave that where it is. But then is it more likely to get 0 or is it more likely to get 1? One of either 0 needs to go down or 1 needs to go up, because you're more likely to get 1 fuse that works than to get no fuses. Sorry, I'm reversing what the chart says. You're more likely to get 1 working fuse than to get 0 defectives. So confusing. So of the 4 answer choices that are left, either you want the choice that's going to kick up the middle bar, meaning you can eliminate answer choice A, or you want a choice that kicks down the left bar, which means you can get rid of answer choice D. And we've already gotten rid of answer choice E. So then you just have to try them both to see which one actually works properly.
Yeah, actually, that's a good point too. At that point, you're 50-50.
You also might just want to guess.
Yeah.
And so if you actually kick that up, right? So right now, if we call this, are they saying what this represents? No, that's just heights. They don't define the heights, right? Hold on, I'm just reading the details. K times the height shown. Okay. So I would call, so again, just eyeballing, estimating this. I would call the height of the 2 bar like half of the height of the other 2, roughly. It's about half, right?
I think they say it's half.
Oh, do they?
Yeah.
Okay. So if we took 1, so we're going to test the 2 answer choices. So answer choice B, if you take the middle bar and you kick, oh, it is half. Okay. So take the middle bar and kick it up to double its current height. Then what you've got basically is 1 to 2 to 4 as the 3 likelihoods. 1 for the number of defective fuses at 2, then 2 for the probability of 0, and then 4 as the height, is the new height. For the middle bar. And that matches this idea that there are 7 fuses and you're slightly more likely to get something that's not defective than you are to get something that's defective. Versus if you test answer choice C, you're going to do what Ryan was talking about before, which is if you have that middle bar, now you've got 0 and 2 at the same, and that doesn't make sense. You should be more likely to have fuses that work than that don't work.
Yeah, taking a step back too, this is something I talk about sometimes in class, but I feel like there are certain problems on the GMAT that are explicitly intended to punish people who treat it as a math test. You know what I mean? Like people who think that everything can be solved with mathematics quickly and efficiently will do poorly on a problem like this because they will always try to do the combinatorics 100% of the time, and they will not consider any other approach. And so I think it sort of underscores the importance of what the GMAT is trying to test, which is number sense, right? Like, are you able to hack a guess in a reasonable amount of time? Understand the story. Yeah. Reading and understanding for sure.
Yeah.
Cool. I like that problem, even though I got it wrong.
Let's take a look at our next one.
Oh God, how did I get this wrong? I didn't even understand this problem.
This one's another weighted average problem.
Let me just read. Let me actually do this problem and see if I can get a fresh look and do it.
It's weighted average, but it's unusual. They're not normally presented in the way that this is, but you can use the same concept of weighted average that we were talking about before to solve it.
Yeah, so it's 2 pounds of chocolate to 3 pounds of peanuts. So basically it's a 2 to 3 ratio, right? So peanuts and chocolate. And because it's 2 to 3, we have more peanuts. So we're closer to this side. And this is like 3/5 of the distance. This is 2/5 of the distance. And this is 380. And are they saying this is a distance of $2?
Exactly.
Yeah,
exactly.
And then the chocolate is more, right? Oh, interesting. Okay, so if we split that $2 range, this is going to be $1.20, and this is going to be 80 cents.
Yeah, so because the ratio has 5 parts to it, you can take that $2 and you can split it into 5 parts, which is 40 cents per part. 40 cents times 5 is $2.
Got it. Yeah. So the
So
peanuts.
the
Yeah.
2/5 represents 2 out of the 5 parts. So since each part is 40 cents, that's 80 cents. And then the 3/5 represents 3 out of the 5 parts times, so 3 times 40 cents is $1.20. So basically the differential here between the two is this, like one is 80 cents below that $3.80 average, weighted average, and one is $1.20 above. And the chocolate is the one that's above. Because the chocolate costs more than the peanuts. So they asked how much the peanuts cost. So the peanuts are $3.80 is the weighted average, minus 80 cents is $3.
This is how I should have done the problem.
This is a pretty sophisticated weighted average problem.
Yeah. Cool.
Yeah. So the $2 is basically, you can think of it as the distance, since this line represents the dollar amount, right? So you can think of that $2 as the distance between the two. And the distance between the two is always in proportion to whatever their ratio is. So basically 3/5 of that $2 gets allocated to one of them, and 2/5 of that $2 gets allocated to the other one. And you don't even necessarily need to think about the math too much there about like who is weighted more, who gets more essentially of that money, who's getting the 3/5 and who's getting the 2/5. So we have 2 pounds of chocolate to 3 pounds of peanuts. So the weighted average is pulled closer to the peanut side of things, like the number that's going to be associated with the peanuts should be closer to the 380 because there's more peanuts in the mixture. So one of them is going to be 80 cents away from 380. One of them is going to be $1.20 away from 380. So it must be the peanuts that are 80 cents that are closer essentially, because they're weighted more heavily. And then the problem also tells you the chocolate costs more than the peanuts. So you know which direction to take it. It's got to be 380 minus 80 cents to get to the peanut amount. Weighted averages are pretty intricate. We've seen a couple of weighted average questions already. If you're like, whoa, this is blowing my mind, what's going on with this weighted average stuff? You do need to master regular averages first before you can get to weighted averages. So first, just take a look at the statistics. If you have all the quant guide, you can take a look at the statistics chapter to master just regular averages. And then there's another chapter in there that's specifically about this stuff, about these annoying weighted averages. This concept, by the way, if you can really master weighted averages, it's going to help you in work and B school, because it's really, really common in the world it's much more common in the world to be dealing with weighted averages than to be dealing with regular averages. But it's sophisticated. You've got to do some training to get yourself used to weighted averages.
I'm steamed about this one because I was 50-50 and I got it wrong. So this one I guessed, but I guessed that one of them made a positive negative error. And I guessed that it was John, but I did not realize it was Katie. So that's why I picked -6 and -2.
So I've gotten this question too on a practice test, and the way that I approached it, you were like, oh, so I should try the answer choices. Oh no, wait, that would be annoying. Write out what John got and what Katie got, even though you know they're wrong.
Okay, so ax squared plus bx plus c equals 0. So
But
John,
don't start from there. Start from their solutions.
Yeah, so John got a times 36 plus b
not from there. Not from there. No. Start from their solutions. You're going how they solved. You know that John got 6 and 2 as his solutions. So what was the final step before he got 6 and 2 as his solutions?
Oh,
once he got it into FOIL form.
Oh, just to, oh, so like x minus 6 equals 0, like that.
Yeah, exactly. So write out the two like parentheses, right? Like as though he, like not even like that, but now put it into
yeah.
right,
So
work backwards.
Yeah, so John got this.
Right. But you know something's wrong there. And then what did Katie get?
Yeah, and Katie got x plus 7 times x.
And so what we're doing here is we're starting from the end of it, like at the end, John would have gotten himself to x minus 6, x minus 2 to get x equals 6 and x equals 2. But there's a mistake somewhere in there.
Yeah, so this is what John had.
Right.
This is what Katie had, x squared plus 8x plus 7.
And then it tells you which one each of them got wrong, but that means that they got the other part right.
Oh, yeah. Okay, so John messed up the 12. So it was actually plus 7.
Yeah.
So
John messed up the plus 12. Katie messed up the plus 8x.
Oh, neat.
Yeah.
So then plus 7 minus 8, that's x minus 7 times x minus 1. So x equals 7 and 1.
Yeah. I've never seen a question. I've never seen them do a question like this one before. It was really.
Can I tell you what annoyed me about that? Is that I wasn't sure whether A was going to be an issue because, but it does say A and C are correct in both. Okay. I thought it said A and B were incorrect, so I misread this.
Okay. So that's why, okay, got it. That's why, because then, yeah, the little trick that I did wouldn't have worked.
Yeah, as long as you know A is correct, then it's just a BC issue that changes things. Okay, well, now I'm not so. All right, then last one. Oh yeah, this one was gnarly.
Yeah, not a fun problem.
But in case you guys ever see this, so the expansion isn't so bad, right? This
Speak for yourself.
Yeah, a plus b squared is equal to a squared plus 2ab. Don't forget that.
Yet another of the 3 quadratic identities. Please memorize these.
Yeah, by the way, this little puppy that I have behind me, I say in my class, every time you say that this is equal to a squared plus b squared and you forget the 2ab, this puppy goes to jail. And I put him behind bars. So that's all that. Anyway, so yeah, you can you can use this quadratic template, and you're going to get 8 factorial plus 2 root 8 factorial root 9 factorial plus 9 factorial.
And I'm going to start with, okay, so you need to do that all, but even before we go into don't go into all the math yet. Hold on a second. Let's just go to like, how do you know what question you're trying to answer? So they're asking for the greatest integer n such that 2 to the n is a factor of something. You knew where you were going with this. You didn't say it till the end though. How did you know where you needed to go from that language right there?
I've seen it a million times.
I know, so explain it.
Anytime they start asking about something being a factor of something else, or the second thing being divisible by the first thing, right? Same question in reverse. Anytime they start asking about, is this a factor or is this divisible by, I'm like, oh, is it in the prime factorization?
Does it have enough blahs, 2s, 3s, 5s, whatever it is they're asking about?
Yeah.
So what about this 2 to the n thing? What does that mean?
Yeah. And so the prime factorization of 2 to the anything is just a bunch of 2's, right? For example, 2 to the third is 2 times 2 times 2. And so when they ask what's the greatest, they're basically asking how many 2's can we stuff in there, right? How many 2's are going to be in this prime factorization of this ugly thing? So that's what we got to figure out.
So that right there is hard, even to just decipher that. That's one of those things that like you've got to, as Ryan was saying, you've seen it before, you've practiced it before, and you know how to just translate that right away to be like, oh, they're asking me how many 2's are in this thing. Whew. Okay, I need to be able to recognize that pretty quickly, because then there's a huge amount of work to do to figure out how many 2's are in that thing. So if it takes me time to figure out even what they're asking in the first place, how many 2's, forget it. I'm not going to have enough time to also do that, dismantling of that horrible number to figure out how many 2's are in there.
So then 8 factorial plus 2 times root 8 factorial. And then here's the thing. 9 factorial is 8 factorial times 9. that shows up twice actually in this problem. So if you think about
and
9
factorial, just as a reminder for anybody who might have forgotten, Ryan's writing it right now. Factorial is take the number and multiply it by every integer that's smaller than itself until you get down to 1. So what he just wrote out right there is 9 factorial.
Yeah, this is 9 factorial. Notice that this is 8 factorial. So this 9 factorial can be rewritten as 9 times 8 factorial.
And why did you do that?
Well, because right now it's under a root. So I can rewrite that as root 9 times root 8 factorial. Or I guess I reversed it. But the reason I did that was because I need to get rid of the square root. So that's my whole goal.
Factorials, right? You got 8 factorial elsewhere, and you're trying to match the 8 factorial.
Yeah. So once I split it apart like that, now I can combine those terms. 8 factorial plus 2 root. I'm sorry, get rid of the root.
Get rid of the root. So 8 factorial times 8 factorial, but taking the square root means you just get rid of the square root.
Yeah. And then I did luck out a little bit. I mean, the GMAT set it up that way, but square root of 9 is equal to 3. So now finally I am free of square roots. Not that we're really done with this problem, because you still have to do 8 factorial plus 2 times 3 is 6 times 8 factorial. And then I'm going to use the same trick again. 9 factorial is 9 times 8 factorial. And the reason I'm doing that now is because I have a common factor.
So you've got 1 8 factorial in the first thing, and then you've got 6 more 8 factorials in the second one, and then you've got 9 more 8 factorials in the third one. So you can add them all up. 1 plus 6 plus 9 is 16. So you've got 16 8 factorials total.
Yeah. So now at long last, it's in a form where I can think about what the prime factorization of that would look like. So it was still annoying because I was like, well, 16 is 2222. But then 8 factorial.
You still have to write that out.
Yeah, I still have to figure out how many 2's are in there.
Yeah, this was a nasty problem.
Yeah, so but I'll do it the long way. There's 1 here. There are 2 more here. And then there's 1 more here. And then there are 3 more here. But then of course
I had a question on my last practice test where I needed to do something similar, but I was counting the number of 5s.
Oh, that's
in
fun.
multiples of 5, and I got to 25 and I accidentally only counted 1. And I got the question wrong because I counted 25 as having just 1 5 and it has 2 5s.
Yeah.
Very annoyed with myself. I didn't actually write it out the way that you're writing it out. I did it in my head, and that was my downfall.
Yeah, is that one of the lessons we're learning tonight? Is that when we don't write steps, we screw up?
You have to write it out. You have to write it out.
Yeah, and it's funny, like that's something I preach. I should follow my own advice. Is kind of what I'm learning tonight.
Yeah, have to write it out. Okay, that's question 21 of 21. Other questions, thoughts, comments? Anyone have anything else that they want to ask Ryan about this fun test experience? Ryan, this was your first focus practice test?
Yeah.
How you feel now?
I feel okay. I feel like I'm definitely glad I did this because it reminded me of things that I need to focus on. So one thing, I am usually stronger on quant than I was on this test.
I think you were working at, you had a sort of a double disadvantage. Actually for the whole for this, it didn't really come into plan verbal, but for this and for data insights. First, you were doing all of your scratch work on a screen rather than on paper. And that is just slower than doing it on paper. It just is. But you had to do it that way to show everybody what you were doing. And then I didn't think about it for the data insight section, but I thought of it when you were doing today, when you were doing this section. When you went back to redo a question, you had lost all your work because you'd erased your work. Where on the real test, of course, you would flip back to, wherever you had done that work. Or sorry, that's only in a testing center. But on the real test, if you're taking the real test online, like
if you're taking the real test online, ideally, so you need to provide your own whiteboard. Ideally, get a whiteboard that is double-sided. You are allowed to have that if you can find one that's double-sided. And so if you know that you're marking a question to bookmark it to come back to it later, box off that work that you've already done and just leave it, don't erase it. Go erase everything else as you continue through the test, but leave that there, write the question number next to it so that you can come back and look at your work again later. You don't have to start all over again from scratch, because then that's just going to take longer.
Yeah, yeah. I will say though, like, I don't feel like my quant was disastrous. I think there were 2 questions that I really should have gotten right that, you know, I would expect to get right on any given test day. Other than that, like, some of these, like, I'm kind of mad that I missed them, but, like, you know, they were hard. I'm fine with it. And it was a pretty decent score. Really what killed me is the data insights, that one multi-source reasoning question. And it's interesting. I mean, you guys heard me say I thought my score was going to be a 685. Which is like decent, you know, it'll give you a chance at whatever business school you want to go to. 615, you know, I'm going to be taking that test again for sure. And it was just really, honestly, it was that one multi-source reasoning question.
It was that multi-source reasoning. For those of you who haven't gone back to watch it, go back and watch the video. You'll see it. It's one of the hardest MSRs I have ever seen, including on the real test. It was a horrible.
Yeah, and what I should have done, if I had just skipped all 3 of those, you know, guessed on all 3 of those, or even 2 of them, and tried to go back, like I was, you know, you notice also I learned my lesson today. I started skipping questions and bookmarking them to go back. Then I would have been okay. A couple things, just now that I'm thinking about it. One is that goes to show you timing is probably way more important than accuracy on this test. You just got to manage your time well, or it torpedoes your score. If you're inaccurate, that will not torpedo your score. It will just slightly damage it, and you can still be okay, right? You can still recover. The other thing that I didn't really think about going into this practice test is that the Focus edition is shorter. Each section is shorter than the old edition of the GMAT. And so on the old thing, I could kind of recover, you know, I had more like wiggle room if I had a couple questions that I can do really fast, which I'm used to. I mean, you saw it on Quant today. There were a couple of these where I was like, oh, 30 seconds, I'm done, because I've practiced them so much.
Right.
I don't
You
have
don't have as many opportunities because there are fewer questions now.
Yeah, and so that really, I think, also hurt me on the data insights, is because I messed up that one MSR, there was no recovery, and I'm not used to that. So yeah, I learned a lot from doing this. Don't repeat my mistakes. Have a timing strategy going into the test. And that's my main takeaway.
And I'll say, Ryan, too, I think it's a good experience. A lot of our instructors have historically done very well on standardized tests. That's why we do what we do. And so we don't have a lot of crash and burn experiences that our students will have. And I think it provides a good, you know, empathy moment to realize, like, oh, wow, here's how you can really get yourself into trouble on this test. You know, we're human too, even though, yes, we like to take these tests and have taken them a lot. The test can get you, the test can get anybody.
Yeah. So quant and verbal scores, I'm relatively happy with. Data insights,
Yeah, you gotta get back in there.
I'll practice that one.
Yeah, you'll be good. You'll be good. I don't want to leave it on a down note, though. The test can get anybody, but also you can learn to do well and get a score that you're happy with on this test. Always write down your work. Always work systematically. Don't hesitate, much like the real world, don't hesitate to look at something and be like, oh yeah, that's not happening today. We do this every single day at school and at work. I certainly look at my inbox every day and I'm like, oh, I'm not even touching that email today. I can't handle it. That kind of functioning executive reasoning is really important when you're taking this test. It is designed to press you and to be harder to do than you can reasonably complete in the given amount of time, because it's literally trying to mimic real world decision making where you can't do everything that's tossed in front of you every day. And so they are literally trying to test you on your ability to recognize, I'll call it, good investment opportunities and bad investment opportunities, right? To actually make that distinction and to be able to say, hey, I'm going to invest here and here, but not this one, that circle question with the whatever. No, I'm definitely out there. That's literally not worth my time, given everything else that I have to do.
And the algorithm is built to allow for that. You're not going to get all of the questions right. Nobody gets all of the questions right because the algorithm is literally adapting to you as you take it. So it's just going to keep getting harder and harder. It's going to find your limit. The key is to recognize when it has found your limit and to be, to have that executive reasoning ability to be like, okay, good, you got me. I'm walking away from this one. Or if I really, I'm stubborn, okay, now at least I can tell myself, well, I'll bookmark it and I'll come back to it. And if I don't have time later, that's okay. At least I've pulled myself out of the question and moved on to other things that are actually better opportunities for me to earn some points.
I have one other final positive thought too that I just want to mention real quickly.
Go for it.
I want to emphasize the importance of reviewing your practice test, because I think what happens a lot of time, especially like if you don't get the score you want, which is usually what happens on a practice test, to be honest, right? Because you're not ready for the real thing. There's the temptation to just be like, oh, this is terrible, and never look at it again. But I mean, you kind of saw the rigor with which Stacey and I are going through each question and like really thinking about, oh, should I have estimated? Oh, like, but how could I have seen that in the moment, et cetera, et cetera. And I really think like that's where the work is, and even like, the years of experience we've had teaching this test, we're still doing that, on every single question. And so it's okay, it's just a practice test. That's the whole point of it. But like, see what you can learn from it, because usually it's a lot. And, I'm very glad that I had this experience. And I hope you guys are too, when you go through the trouble of taking a full practice test.
Yeah, that's an excellent point, Ryan. Thank you for adding that. I took a practice test myself earlier today and spent about an hour afterwards reviewing it. And I'm nowhere close to done. I'll spend multiple additional hours later this week reviewing that test.
Same on this one.
Yeah. Well, thank you so much, everybody, for coming. Ryan, thank you for being our guinea pig on doing this and taking a test live in front of the world. It's a nerve-wracking situation. So I really appreciate your willingness to dive in and to do this. If anyone has any questions, we'd be happy to hang out and answer questions. If you are good to go tonight, please feel free. Oh, we got a request to go take a look at question 20. So pop that one up.
Sure.
I did put in the chat a link to, we have a free ebook on Foundations of Math. It's available on Amazon for free. Feel free to go grab that. If you don't have it already, download it. We do also have 2 free Foundations of Math workshops that are run once or twice a month. You can look on our website to see what the upcoming schedules are for those. Like that's the place to start, is to make sure that you have really solid foundations. So you can then build on it with a lot of the harder stuff that Ryan showed us today. And if you're good to go, the peanut and chocolate question. Which one's the peanut and chocolate question? Oh, that was the weighted average one. Yeah. Sorry. So anyway, if you're good to go, feel free to take off. We're gonna answer some last few questions here, and good luck with your studies and with B school eventually. Thank you for coming. Okay, where's that? Oh yeah, that one. Yeah, so this one's pretty intricate because of that weighted average idea. So there's the thing that I was talking about, but the thing that we showed the last time we looked at this problem was sort of the most elegant or quickest solution, but that's only going to work for you if you really fully understand how, like, all the ins and outs of how weighted average works. The first clue on this one to recognize that it's a weighted average is that it's talking about a mixture. It actually uses the word mixture right at the beginning of the sentence of the problem. So the cost of a mixture, boom, immediately be like, oh, is this a weighted average? And then they tell you that you've got chocolate and peanuts, and there's not equal amounts of the two. So there's 2 pounds of chocolate to 3 pounds of peanuts, meaning there's more, that it's a ratio of 2 to 3, but also there's more peanuts than there is chocolate. So peanuts are weighted more heavily in the lovely chocolate coated, candy coated, whatever piece of candy that you have in your hand right now and are about to eat. I wish I had some right now. That would be great. And then Ryan, you want to start, you need to draw it because you've got this.
I have an idea. I realized what's annoying about this is the pounds. And I'm realizing now that it's the same problem if you just ignore the fact that it says
2 chocolate
pounds.
pieces and 3 peanuts.
Yeah, and then per pound.
How do you know though that that's allowed?
Maybe let's circle back to it. just trust me for now. And think about it like this. If you have a mixture that has 2 chocolate pieces and 3 peanuts, what it's saying is that's like an average of $3.80 per thing.
Like I have to pay, I'm in the candy store, if for each piece of chocolate that I buy, I pay X dollars, and for each peanut that I buy, I pay Y dollars.
Yeah. And then the second piece of information is that the chalk, one chocolate guy costs $2 more
Than one peanut.
Yeah, than 1 peanut. So maybe that can be a easier way into this problem. And from there, you can solve it as a weighted average, or you can solve it algebraically, however you want. But that's essentially what the setup of the problem is.
And I would say too, I guess I can draw on screen, can't I?
Okay.
I should be able to. I'm just grabbing a different color than you. I'm not used to having to do it as a participant. Right there's mine. Now, how do I change my color as a participant? I'm used to seeing there we go. I'm used to seeing this as a teacher. Okay, so this purple color now is me. So you're saying it's an average, right? Like the overall average, I'm paying $3.80. But it is the case that there is actually a difference in what each one of these costs versus what each one of these costs.
Yeah.
And so
I'm realizing now how you could do the algebra, by the way, but go ahead.
And so the chocolate pieces cost more. So I'm going to do this. The peanuts are cheaper. The chocolate costs more. And specifically it costs $2. Like each of these costs $2 more than each of these. And so from there, how would I do this in a way that doesn't require me to already fully understand how weighted averages work, which is
I can hop in. I know.
Go.
I'm going to steal your color here. That piece of information that you just wrote, you can say chocolate minus peanut equals $2. And I'm establishing C as the price of 1 piece of chocolate, P as the price of 1 peanut.
Mm-hmm.
And then in order to weight the average, because you have 2 chocolate pieces, you can say that's 2C. Because you have 3 peanuts, you can say plus 3P. And because that makes 5 total things, you can divide that by 5, and that's going to equal $3.80. And now you have 2 equations, this equation and this equation. You have 2 unknowns, so you can solve that, and you should end up with P equals 3.
And use it to specifically try to solve for P, since that was the thing they asked for.
Yeah. So if you don't want to do the weighted average, I guess you could do it that way. And if the per pound thing is really confusing you, now we understand, we can just say, well, this is pounds of chocolate. This is a pound of peanuts, another pound of peanuts, and another pound of peanuts.
Yeah,
and
but
then,
it doesn't change the math that you're doing.
Yeah. So if you just insert that, then it's the same product. Sneaky.
And you could also, although it might be more trouble than it's worth, you could, because the answer choices represent the cost of the peanuts, you could work backwards potentially from the answer choices. If you weren't sure how to set up those equations, right? You could say, okay, well, what if the peanuts cost, $1.80 a pound? What would that mean for?
Yeah.
And you could see that would be too much, because if each peanut was $1.80 and they're supposed to average to $3.80, then each peanut is $2 under the average. So collectively, the peanuts would be $6 under.
Yeah, that's true.
And that's already wrong, actually, because you want the differential between peanut and chocolate to be $2. If the differential between peanut and average is already $2, the chocolate has to be more than that. So that's already more than $2. So answer B would be wrong, and answer A would also have to be wrong because same direction. So then you try 260 next. If each peanut is 260, then each peanut is $1.
Chocolate is 4 cents.
Oh, sorry.
Oh, sorry. Go ahead.
If each peanut is 260, then it's $1.20. Each peanut is $1.20 under the average. So collectively, the 3 peanuts are going to make you short $3.60. $1.20 times 3 is $3.60. So the 2 chocolate pieces have to make that up. I should be writing this all down. I'm talking out loud now and saying this, but again, you'd have to, yeah, I should be writing this all down.
Yeah, there are lots of different ways to do this problem, which I think is maybe one of the things that makes it hard to study, right? Because there's so many different directions you could go. You could do it as a weighted average. You could do it as a straight average, which is what you guys are seeing on screen. A lot of stuff. I actually thought of a question for you, Stacey, that people might be interested in. Do you have any idea of how much my data insights would have to go up if I were to reach like a 655, get into business school threshold?
Really good question. So there's not a lot of data out yet in terms of what combination of scores get you, of sub-scores, section scores get you to a certain overall score, because it hasn't even been a month yet since the official test was launched. So we're basically still gathering data. Lots of websites are gathering data. I think GMAT Club has put something together based upon taking practice tests. We're not quite sure that the practice tests will be exactly the same as the real test. So we're waiting until we get enough data from the real test to be able to tell that.
Yeah.
So I don't have an answer for that today. Give us another couple months of gathering real test score data, and we should start to have an idea.
Yeah, that's not...
Other questions, other thoughts on any of this, on individual problems or on just the overall test? Oh, and sorry, I'm seeing some additional. Some people are asking, someone's asking, is the GMAT Focus harder than the classic? I think that would depend on your own strengths and weaknesses, because there are some changes to the GMAT Focus compared to the classic. So for example, the classic exam included grammar in the verbal section. If you liked grammar, then you're not gonna like the Focus quite as much because grammar has been removed. If you hated the grammar, then you're gonna prefer the Focus because you no longer have to worry about the grammar. On the old test, what used to be called the integrated reasoning section wasn't included as part of your total score. It's now called data insights, and it is now part of your total score. So again, depending upon how you feel about that section, you may or may not be thrilled about it being included in the new score. Like in terms of just objectively what the test is, no, the new test is not any easier or harder than the old test. It's still the same test questions and still mostly the same content besides the things that they've removed. But for an individual, depending on your strengths and weaknesses, you might think one of the 2 tests is easier or harder for you. I will say that one of the things that I really like about the GMAT Focus is that the things that they removed from the test are things that weren't really particularly helpful for business school anyway. So like the grammar, most of geometry, the essay, the stuff that remains, not all of it, but a lot of it is stuff that's actually relevant to the kinds of work, the kinds of thinking, the kinds of skills that you're going to need to have to succeed in business school as well. So it's basically more relevant, what's actually being tested than the stuff on the old exam.
I will also say on the data insights piece of it, I know some folks who are like, oh, I wish they weren't putting data insights into the total score, that it wasn't part of the total score now. Yes, for people who are not super excited about data analysis or stats type stuff, I can see why that would be considered a drawback. I will say your goal, if you're taking this test, is to go to business school. And in business school, you will be analyzing data every single day of the year, like of the 2 years that you're there.
I say that a lot. If you don't like data insights, why are you going to business
Like,
school?
like this is
There are other
business
graduate
school.
programs.
Right? This is business school. So if now you don't have to already know all about stats and data analysis to start business school, but if that's something that's making you nervous, then I actually think it's an opportunity to use the GMAT to get yourself feeling more comfortable with all of the baseline level knowledge around reading graphs and tables and charts and performing stats calculations and whatever, because you're going to do a whole lot more and a whole lot more advanced stuff in business school. So at least when you start at day one of business school, you won't feel like you're completely at sea and you don't know anything. You'll have some baseline level of knowledge just from having studied it for the GMAT. So I would actually use that as an opportunity to help yourself feel more comfortable, from day one of business school. Oh, and yes, Rano, thank you for that suggestion. Sorry, I'm just seeing your QA thing now. You were making a suggestion for that last problem that we were looking at. And someone's asking about for data insights, how can I effectively prepare for it if I only have books for the classic? So on the classic exam, the equivalent section was called integrated reasoning. So if your materials are for classic, you're looking at the materials that are labeled integrated reasoning in those materials. Those 4 question types are still in the data insight section on the new exam. And then what they also did was they moved the data sufficiency problem type from the quant section to the data insights section. So you've got all of the material that you need in your classic materials, if that's what you have. It's just that they renamed that section and they've kind of reorganized a little bit by moving data sufficiency from one section to another section. Let me know, maybe it's the case that the materials that you have didn't include the integrated reasoning section. If that's the case, then yeah, you're going to need to get materials for integrated reasoning or for data insights in order to prepare for the focus. But if your classic materials include everything that was on the classic, then you do have everything that you need. What you're going to do is just out of your classic materials, don't study geometry except for coordinate plane, and don't study grammar, but study everything else that's there. And let us know if you have more questions about that. Thank you, Ryan, for illustrating. And also, if you have the classic materials, there's no essay, so you can ignore the essay stuff.
Yeah.
There's no essay on the focus. Anything else? The other thing that I would recommend, if you're specifically looking for more data insights practice, particularly the 4 question types that used to be known as integrated reasoning, with the new official guide that was published in June of this year, it's the OG 2023 edition. They added about twice as many questions of those 4 that used to be called integrated reasoning. So for the old OGs, OG 2022 and earlier, there were only about 75 to 80 of those question types in their online platform, and they now have like 150, 160. So if you don't have the official guide 2023 edition, I would recommend getting that. And you were specifically looking for more data insights practice, I would get the OG 2023 so that you get access to more questions. Yes, one of my students just told me today that they've been using the online thing, and that what they were getting with MSR was, when they did the random problem sets, was splitting MSR up into, like, it wasn't giving the MSR questions together. I didn't notice that when I was doing it, because when I did it, I had it give me all the MSRs at once because I just wanted to do them all at once. So what I would actually recommend, there's a workaround. I'm going to report that to them and hopefully they'll fix it. I think it was just a mistake because the reading comp is delivered properly with the questions tied to the passages. So I'll report it to them, but I don't know how long it will take them to fix it. What I would recommend doing in the meantime is go ahead and do a section where you ask it to give you all of the MSRs. And when I did that, it actually gave me the MSRs in the right order because I had it give me all of the MSRs at once. So then basically you can save that section and then just go in and do an MSR or two at a time, and then just keep kind of like saving it and coming back to it. So that way, at least you'll see them all together.
That is a solid tip, Stacey. I did not know.
But I'm going to email them to point that out to them. I'm guessing that there's some kind of a bug or something like that. Other questions? Okay. All right. Thanks for joining us. Like I said, if you do want to get some more, free teaching, free practice, free stuff on this, go download our Foundations of Math ebook. The Foundations of Verbal ebook is also available on Amazon for free. We do have 2 free Foundations of Math workshops. You can also do those. They're 5-hour-long workshops. Please join us. And then we do also have what's called free prep hour. So a couple times a month, we have just free hour-long sessions where a teacher comes on and teaches whatever they feel like teaching for that hour. And you can come in and learn whatever it is and ask questions. So we hope to see you in future. Thanks for joining us tonight.
Thanks, everybody.
And we'll see you soon.